All right. Today is September 3rd. What we're going to do today is spend some more time looking at a lesson on area of rectangles. And it's kind of an interesting day because we're moving from area of rectangles to areas of shapes that are made up of rectangles. So we're going to use what we know about finding the area of rectangles and apply it to different shapes. So our target is to determine the area of a rectangle without a grid using multiplication and addition. All right, so the last few days we've been using multiplication of rows and columns to find the area of a rectangle. Now we're going to add another piece to it with addition, where we can find the area of pieces of a shape that are a rectangle and then add them together using addition. Your homework, this class has been really good about turning stuff in. So if you already completed the no more squares, that first bullet, you don't need to worry about it. It's due at tonight at midnight, though. If you aren't finished, please get that done and turn it in. And then the second bullet is what we are going to start today. So I'm going to stop sharing my screen. You should be able to see me. Now I'm going to go through all the steps needed to pull up the notebook. Let me get that there. Okay. So share my screen, first screen. Okay. So you should see a warm-up activity. You give me thumbs up if you see it. Okay, great. So what we're going to warm up with today is looking at some addition problems and going through some strategies about how we make a 10 to make mental math easier for us. So these aren't ones you're doing on paper, but I want you to explain how you would add, let's look at the first bullet first, 109 plus 4. How can we make a 10 out of that and make it easier for us on our mental math? Malia?
Forget the 1 and the 0, add the 4 and the 9 and equals 13 and 113.
Okay, can you explain that again real fast? Sorry, it kind of...
So forget the 1 and the 0 and add the 9 plus the 4 and it equals 13 and the answer would be 113.
I gotcha. So you're cutting off the hundreds and the tens marker, and you're looking just at the 9 and the 4. And you say, all right, I know what 9 plus 4 is, and that equals 13. And now that I know what that piece is equal to, I can just add that 100 back to it to get 113. Yeah, that's very good thinking. Thank you, Malia. For this, let's see, let's go to the second one. Okay, because it's a little bit more difficult problem. We can maybe use what Malia said, her strategy was for the first, but do you guys remember making a 10 last year with Mrs. Thornton? You find the nearest 10 because a 10, as one of the people from First Block said, 10s are friendly numbers, right? They're easy to do in our head. So when we're trying to make a 10, oops, let me bring that back up. When we're trying to make a 10, the reason why we're doing that is to make it easier on us. So let's walk through 109 plus 14 real fast. I gotta let Mrs. Eddy in. Every time I let someone in, it changes the screen. But if I were to look at 109 plus 14, what's the nearest 10 that 109 is closest to? Adelina?
It is closest to 10.
Closest to what 10? Or 109?
It is closest to 109 is closest to 110.
Okay, very good. So it's closest to 110. If we're trying to get to 110 from 109, what do we need to add to it?
1.
1. Okay. And if we're adding 1 to it, what happens if we take that 1 from 14? What does 14 become?
It becomes a 4.
Well, so we're not taking away a 10, right? There is a 1 out in front of the 4. But if we're subtracting 1 from 14, then what are we
13.
left with? 13, right? Yeah, and these are the same things, right? 109 plus 14 is equal to 109 plus 1 plus 13, because this grouping here in the parentheses is equal to 14. Would you agree? 1 plus 13 equals 14. Okay. So the nice thing about when we're adding these numbers in a straight line is that we can move that parentheses around. We can actually write it as 109 plus 1 plus 13, but instead of grouping the 1 and the 13 together, we'll group the 109 and the 1 together. I'm going to switch. I have to let Katie in real fast. Okay, now we can group this 109 and 1 to equal 110. And then we have the 13 still attached there. What's 110 plus 13, Adelina?
110 plus 13 equals 124.
Very close. Check your ones.
Oh, 125.
Check your ones again. If we're adding a 3 ones to a 0 ones, what do we get in the ones digit?
3 ones to 0 ones would be. So I think I would switch the 3 to the 110.
Someone want to help her real fast? You're very close, Adelina. 110 plus 13. Camila, you want to help her?
123.
Yeah, 123. All right, super close. You said 124, Adelina. But when we're adding 110 to 13, or 13 to 110, that last digit is going to be a 3, because the ones digit is a 0 here, and we're adding a ones digit of a 3 here. So 3 plus 0 is 3 for that last spot. Does that make sense, Adelina? Okay, let's do one more. Let's look at 209 plus 34. Can someone walk me through the similar step that we did up here, where we are trying to find the nearest 10 that 209 can go with, and how we take it away from 34, and walk me through that process? Malia? You're on mute.
209 plus
What's the nearest 10 that 209 is?
210.
Yeah. So we're
Plus-
trying to get to 210. How can we make 210 out of the 209 plus 34?
Add 3 more 10s.
Okay, let's not get too far ahead of us. We will eventually add those that 34 to it. But if we have 209, okay, and we're trying to get to 210, what do we add to 209 to get to 210?
Plus 1.
Right, so we're adding 1 to that. Now this 1 has to come from somewhere, and it came from this 34. So if we took away one of the ones from 34, what's 34 become?
33.
Exactly. Right, and these are the same exact things. We have 209 plus 34. That equals 209 plus 1 plus 33, right? Because this last grouping here is equal to 34. All right. Now, like we did up top, we can move that parentheses around and group the 209 plus 1 plus 33. Okay. You want to take it away, Malia?
Equals
What's this equal? 209 plus 1.
210.
Right. And we're adding 33. So it's 210 plus 33.
342. 3.
343? Did we add it?
243.
Right. 243. So we'll get more practice with this throughout the year, just like the other warm-ups where we are quickly counting the dots. And we did that a couple times this week. We'll do these extending to make a 10 multiple times throughout the year too. Okay. So as long as you understand the idea of regrouping to find the nearest 10 and then add the remainder to it, you're in a good spot. But we'll get more practice with this later. Okay. Let's get to the activity. Okay. So this is the next thing that we will work on. First and foremost, let's spend maybe 30 seconds to a minute just doing some notice and wonders. What are some things you notice about this shape? What are things you wonder about this shape? Let's spend a little bit of time looking at this shape. Okay, I see a couple hands. That's great. I'll call on Eileen and Camila in just a second, but I want everyone to have a chance to look at this shape here. All right, Eileen, go for it.
I noticed that the squares are not full. They're like half.
Okay, yeah, there's some in this little squiggly area here. They're unmarked. Okay. Do you think that affects our ability to maybe like find the area of this or anything?
Probably.
Probably. Okay. When we weren't using grids yesterday and rectangles, did we have any issue finding the area?
No.
No? Okay. But you think it might impact us here? Might change things for this?
Yeah, a little bit.
Change a little bit. Okay. Camila, what do you notice and wonder? Oops.
I noticed that there's a blank spot where there's no line.
Okay, so kind of like what Eileen was saying, there's some areas that aren't marked. All right. Adelina, what do you notice?
I noticed that we did this actually last year when we were in 3rd grade with
You
Mrs.
did?
Yeah.
Awesome. Yeah, that's good because we are doing the last little bit of the 3rd grade book before we get into starting this unit. So this should look familiar. It might not look familiar, but you had some exposure to this last year too, which is good that you recognize that, Adelina. Katie, do you mind moving to a different spot? I see some gaming going on behind you. I know you're not playing it, but let's find maybe a quieter spot for you. Okay, or that works too, as long as you can focus. It was just distracting me. Okay, any ideas about how, those are all good things, Adelina, Eileen, Camila, thank you for sharing. Any ideas how we can maybe find the area of the shape? Malia?
To find the area of the shape, just count the columns and rows.
Okay, go into some more detail on that. I like your thinking. How can we use the columns and rows to help us?
To count the area inside of the.
Yes. Oops.
To. So to count the area inside of the, to count all the squares inside of the area.
Mm-hmm.
And there. For the ones that are blank, there's 2 more squares to add.
Okay, 2 more squares to add. Where would I do that?
Finish the lines into a square that matches the top.
So something kind of like that.
Mm-hmm. And the area inside of it would be 28.
28 in which piece?
In the looking like a rectangle and square.
Looking like a rectangle and square. So
The
where would
top
we
one.
cut off the rectangle and the square?
At the bottom of the column.
So down here?
Mm-hmm.
Okay. And where does it, I might need a little bit more help explaining where you're cutting it off and how you're getting those numbers. You're on a good track here, Malia. Do you care if I go to Camila and see what she's thinking? Okay, nice job, Malia. So Camila, you can run with Malia's idea, or you can share something from the start.
I have a question.
Go for it.
So on the other square that like has a blue line, is it a different square or is it the same?
No, it's all the same. Let me erase this so it's a little bit easier to see. How I explain it to the first group is think of this like a bedroom. Okay, and your job is to try to find the area of this entire bedroom floor, right? Maybe you already had, so like the door is over here, there's maybe a window right there, a window right here, your bed's right here. Maybe you wanted to bring in a desk and you're like, I wonder if it will fit. Because you don't have it quite yet, but you're thinking about buying it and you want to see how much area the floor of your room has to see if you have enough room.
Oh.
Does that make sense?
Yeah.
So we have this little piece down here and then this larger piece over here. Okay. Can I ask you a question? Okay. Is there a way, is there a way for us to find the area of this with just like multiplying length times width, or columns and rows in one step? Do we have a rule for this shape?
You could count the rows and columns, and to see how much there is, you could multiply them.
All right. So you're thinking like these columns here and those rows, like these columns, those rows, like that? Okay. How many columns are there?
There is 7.
7?
Yeah.
Okay. How many rows are there?
4.
4 rows over on this side.
Do I also yeah, on that side?
Okay. I'm gonna correct you there. It might be hard to see. There are actually 5 on that side. Let me let in Tania real fast. So there are 5 on that side, 7 across. Now, if we were to multiply those two together, what would that give us the area for? The 7 and the 5?
35.
35. Is that the entire bedroom?
Yes.
So that's all of that, including this little piece down there. All right, Adelina has her hand raised. I'm going to go to her and see what she's thinking.
Okay.
Thank you, Camila.
Okay, so what I planned out is I cut off the bottom little half of it, and I did it as another multiplication thing. That's what we did in 3rd grade when we had this problem. And Miss Darden was like going over it, and she told us that when you have an off shape, you can cut off a side to make it equal.
Mm-hmm.
And you add that other shape that's unequal, and you make it a new equation. So then you add the two. When you times it, then you add the 2 times. So what the answer is when you times it, the answer is that when you times both of them.
I love it, Adelina. Great job explaining that. That's what I was looking for. I was trying to see, get it to come out naturally, but Adelina knew it right away. Good job explaining. So she said that when you have this kind of odd looking shape like this, you can cut off pieces of it and then look at each of those bits and pieces and find the area of those pieces and add it all together. So Camila started to break down this 7 columns on top, 5 rows on the side, which ends up being this green rectangle that I highlighted. And when she took 7 times 5 to get us 35, she found the area of that green Pop-Tart looking rectangle on top. Then we have this little square on the bottom here that we haven't accounted for yet. We cut it off. We found the area of the green Pop-Tart. Now we need to find the area of the blue little square Pop-Tart at the bottom there. So Adelina, I'm going to let you take it away. How do I find the area of the blue rectangle or square in this case?
Okay, so I would say, Jesus. What I would do is I would add there is 3, or I think 3 columns, 1, 2, 3 rows, and then there is, since there's nothing at the top, it's just nothing. There's nothing at the top. I would go down to the bottom because the up and the down are the same length and the same height.
Mm-hmm.
They would be equal either way. So it would be 3 times 3.
Great. So I'm going to keep it color coded so we can tell what we're talking about. What's 3 times 3?
3 times 3 is 9.
All right. And now what do we do?
And what you do is you add 35 plus 9.
Right, because we found the area of the green rectangle. We found the area of the blue rectangle. And so now to get the total area of each piece added together, we need to add the areas of each together. So we have 35 for the green. We have 9 for the blue. Adelina, what's 35 plus 9? Adelina, could you hear me?
Yeah.
What's 35? What's 35 plus 9?
44.
It is 44. So our total area of this bedroom, let's say, is 44 units. So we took the green rectangle, we took the blue rectangle or square, and found the area of each and added it together. Okay, does that make sense? There's a lot of cameras that are off right now. So if you can, please turn your camera on. And I want to see thumbs up, sideways, or down, depending on how you feel about going through this problem. Does it make sense now that we've had a chance to go through the problem? How you can cut it off? Okay, we don't have much time, but I do want to go through the next problem with us, okay? So looking at this shape, can someone explain to me how we could cut off different pieces to help us find the area of the entire thing? Okay, I see Adelina's hand, but she was the one who explained how to go through the last problem. So I want to hear it from somebody new.
We had this exact same one in 3rd grade.
Did you?
Yeah, I remember this shape.
So Adelina was paying attention last year.
Yeah, that's what it sounds like. So we don't have much time, guys. So if you know how you could break this up and cut it up into different rectangles, let me know. Any ideas? Tania?
Can get the bottom square and where you see the line that's cut off from the other square on top, you can make the line and there's 2 rectangles.
Like that? Yep, I think that's a very good way of separating these 2 rectangles. Okay, now any ideas how we'd find the area of each? If we made this a blue and this a green. Nice job, Tania. How can we find the area of the blue rectangle? Thinking about rows and columns here. Eileen?
By counting the half of the squares.
Counting half of the squares.
No, by counting the lines.
Okay. Give me a little bit more detail on that. Counting what lines? How does that work for rectangles? How many columns does this blue rectangle have?
2.
Yeah, it has 2. How many rows? Oops.
4.
2 columns, 4 rows. Okay, how do I find the area of that?
2 times 4.
Yeah, 2 times 4 would probably be the quickest way of doing that. 2 times 4 equals?
8.
8. Okay, Eileen, do you want to do the green one too real fast? How many rows does it have?
8.
Rows or columns?
Rows.
So 8 over here?
No. Oh, columns, I mean.
Yeah. 8 columns. How many rows?
3.
All right, so if we try to find the area of that, how do we do it?
3 times 8.
All right, what does that equal?
24.
Great. Yeah, 24. And if we're trying to find the total area of the green Pop-Tart and the blue Pop-Tart combined, what's the total?
32.
Exactly right. There are 32 units total in this shape. Great job, Eileen. Awesome job. So we're just about done. That was the last problem we're going to work on. Can I see videos? Can I see thumbs up, sideways, down? Is this making sense? Right, we're getting shapes that are kind of strange, not usual shapes, but when we break it down into rectangles, we're able to find the area of each of them and add it together. Right, that's the process that we're using. Okay, I'm going to quickly go over the homework. It's this one problem here. Okay, do you see how this is pretty similar to the shapes up above that we worked on? How it's kind of a weird looking shape, but with some cutting, we can make it into a couple rectangles. You see that? Okay, I'm going to leave it up to you on how you cut it, but there are a couple ways we could cut it. We can look at it like this and look at a left rectangle or a right rectangle, but then we need to do something with this 9 foot right here, right? Because it's not 9 feet anymore. We can do that, or we can even look at it like this and have 2 rectangles on top and bottom. Okay, those are the only hints I'm going to give you. What I want you to do now is, if you have no questions, don't have any questions, then please sign off the video and get started on your work right away. I can see when people view the work. So let me end the recording real fast.